Hi again. I'm back 17 weeks later, or probably a little bit longer for this black sugar carbon snake cell. The salt's probably come out of the solution. It's all climbing up the sides of the electrodes and stuff. I'll just give it a clean up and I'll put the salts back in, top up the electrolyte, and I'll be back. Okay, I'm back. I gave it a quick clean up, put the salts back in each container and topped up the liquid with some distilled water. About 3 weeks ago I emptied the containers and got that green stuff out, which it was green, but this one here had black crap which tainted it all, but the stuff feels like the jelly crystals. It's all spongy like that. And I'm connected in series at the moment for a test. We're at 1.1 volts, and for a short circuit I don't think there'll be much in it. I'll just connect that up to the negative. Nah, see, bugger all. 0.7 of a milliamp. Okay, so we'll just connect it in parallel. Positive to positive, negative to negative. Stick that one in there. Okay, we get 0.6 of a volt in parallel, and for a short circuit, connect that up there, and short circuit in parallel. Oops, must be something wrong. Positive. There we go. We had a little bit more. It went to 3 amps, holding at 1.5. Now I've got the power supply set up on 5. Yeah, 5 volts. I'll give it a bit of a charge. Alright, I'll be back. I'll have to set up some more leads. Back, we'll give it a 5-minute charge. I've got it on the 10 amp range because I touched it and it went over 200 milliamps. And starting the timer, and we're at 280 milliamps. Alright, I'll get back in 5 minutes. Okay, we're at 4 minutes and 40 seconds. We have some bubbling, but not too much. The amperage has dropped down a bit. We're at 150. And voltage is 5.3. We've hit 5 minutes. Okay, I'll just disconnect the charge. Reset the timer. And we'll see what the voltage settles at. Voltage seems to nearly stabilised, 1.69, so the cell's probably still alright. It's been idle for about 4 weeks, just sitting there by itself. Even the electrolyte was right down to about a quarter of the tub. Alright, we'll see if it can drive this motor for any period of time. Alright, a lead down here. Oops. Hook him up. Alright, the motor's working. Set the timer. Oh, haven't got a reading. There we go. There you got 16 milliamps. Motor is moving. Voltage dropped heaps. So, and it's currently in parallel. Alright, so it's pretty much got not much in it. So there we go. We won't even bother. Got a minute probably. 40 seconds so far. But that's good enough for a test there. I'll do the same in series. And then we'll do the autopsy on the cells, because I wanted to find out what the green stuff at the bottom was. I've got a copper electrode on the side. I'm wondering if the copper electrode has actually been eaten away. Alright, won't be long, I'll connect it in series. Okay, got it in series. The voltage is still 2.8 in series. We've got enough there to run the little 2.5 blue LED. If I get a good contact. Okay, and the voltage has only just dropped down to 2.5. It's probably good to run LED. It probably would still run that LED for 24 hours. Or at least 12. It was doing pretty good last time I had it set up in series. That's after charge. In series it was, without that charge we did before, it was 1.13 volts. So for a small little load of an LED, it's not bad. It would probably make a good night light, survival light perhaps. It seems to be a bit of a shame to pull the cell apart. Maybe we shouldn't, I'm not sure. I need the room, we'll do it. For science, we'll sacrifice the cell. It's only an LED light. Alright, I'll be back. I'll have those two out the tub and on the glass, and we'll be dissecting them. Okay. Alright, that's the cell out of the clear tub. It has a distinct green along its side. Okay, so we'll cut the rubber bands. I don't know, we can just pull them off. That'll be alright. This is the material one, and the other one's the paper towel version. So we have, I presume, copper. We'll find out with this electrode. It's going down the carbon piece. So we can break that apart. Oh, yeah, the carbon coating on the aluminium is still good. So that's one good thing. We should have some gel crystals on this side. Put the wrap at the back of the thing. We just have a piece of plastic as a support here. This is the graph. Oh yes, look, it was copper. Check the copper electrode out. Totally gone. See that? Amazing, it was still actually working. And the graphite plastic, I think a lot of it just peeled off. So that's the remainder of the copper. That's extremely thin. I guess it was working because it was all just tightly bundled. And this is graphite stuck to the gel. Oh yeah, that's the other coating which was on the graphite sheet. The gel's still in there. Majority of the gel. Yeah, pretty much I think all the gel's there. It still feels jelly. That's the other membrane, charcoal, and the acetate. So that was that cell. And for the other cell with the paper towel, paper towel's held up pretty well. It's not ripped. Yeah, again with the electrode. So that's the paper towel. That's a clear sheet I've used just for stiffening. Oh yeah, this one's a bit, oh no, she is broken. But there's more graphite left on that one. But it's got a funny red colour. That's the copper electrode was down the side. And again its covering fell off. That's it there. That's that cellulose acetate membrane with carbon in it, which was stuck to the graphite sheet. The nappy crystals, the gel crystals are still in there. And again, the aluminium sheet here, it's not too bad. It's a bit pitted on the outside on this one. And the back is a combination of green and black. So around about 16 weeks, 15, 16 weeks in electrolyte solution. Not too bad. Where's a towel when you need one? Yeah. Well, okay, thanks for watching. That's the end of the autopsy on the black carbon snake cell. Okay.